Good day, good people. Tikuda kuenderera mberi necircle geometry. Takutarisa our second theorem. The wording of our second theorem is this one. Saka ndiyo theorem number 2. Irikuti iyo angles in the same segment of a circle are equal. Saka angles in the same segment of a circle are equal. In order for us to understand this theorem, there are certain things we have to understand and appreciate. Chekutanga, we have a circle like this, and we know if we put a chord, remember taka define a chord as a line which connects two opposite sides on a circumference without passing through the center. So this is a chord. Chord redu takati rinotipa two distinct regions kana kuti parts of a circle. The first part, we are going to have this piece, small piece inoi, and this larger piece. This is going to be called a minor segment, and this is also called a major segment. And of course, tikangotarisa the part of the circumference, kureva this curvature is going to be called a minor arc. And also, the other part of the circumference will be a major arc. So these are the main parts of a circle we are interested in. But for the sake of this theorem, angles in the same segment of a circle are equal. So they are in the same segment. Let us reproduce example yatapiwa. So this is the circle. Panapa we have A and we have B. Then toda is so something like this. And we also have something like that. So it's like this. Then this is the center. Like this. That's the center. We have this angle and that angle. x1, x2. Like that. Saka angle x1 is going to be equal to angle x2, which of course we can write as the angle P is equal to the angle Q. Kana kuti tinokwanisa kuti angle APB, because tikuti APB is equal to angle AQB. AQB. So these are angles in the same segment. If you want to give it a name, these are angles in the same major segment. So one sure way of understanding this, you have to imagine a line. Imagine line panapa. And this could really say, just imagine it. Now, if you imagine a line there, you should then appreciate kuti these two angles, they are in the same segment. And because of that, they are going to be equal. There's something I want to show you, but I have to change screens. I want to show you on a piece of paper another way of understanding this. So what is happening here is we have a circle. Then we have points A and B, which are 2 points on the circumference of this circle. Then from this point A to iso, shinobata pa B panapa. Then to B, shinobata pa A. We have a center, which is always cannot usually O. Then 2 radius akada iso. We have this angle x1 and this angle x2. So we defined earlier on that if we have a chord AB, ka region kanaka kandikuda kusheda aka and kange kachinzi a minor segment. Saka a portion of a circle is called a segment. So this is a minor segment. Of course, this becomes a major segment. What is the wording of our theorem? Theorem yedu irikuti angles inside the same segment are equal. So how are we going to go about it? So zvanangachida kukuratidzai ndeizvi. Of course, we know that the conclusion here is angle x1 is equal to angle x2. That is the conclusion there. But what I wanted to show you, Panaba, is this. If you have the same, my angles are one in the same segment, if you can do them like this, kuti, you can, and this is what I'm going to say, your hand and it can motion like this. Kuti mune angle, irikubva panapa, this is an imaginary chord, yatrukisapa. And kurokti zvese zvazvawanikwa pai mu major segment. So if you can do like this, muchibuditsa x1 and like that, muchibuditsa x2. If it were on a small paper like this, what I mean is you are getting an angle panapa, and from the same imaginary chord you are also getting another angle. That's one way of looking at it. But if you want to be technical about it, then it's simpler. You just have to know kana zvinhu zviri inside the same segment, the angles here are going to be equal. So ndo roughly zvandanga nchida kuratidza, but I know that with more practice it will begin to make sense. So let us look at some few practice questions. Tikatarisa panapa, as we can see, tiri kuona kuti angle A, B, C and D are going to be equal because they are inside a major segment. But my angles are as I wanted to illustrate on our board, or let me just do that. I want you to appreciate something. My angles are always going to be formed as a vertex. So the word vertex, in plural it's vertices, zvongoreva a point inogadzirwa panosangana two lines like that. So these angles are going to be formed parikusangana this line rikubva pa A ne that line rikuenda ku B, and this line rikubva pa B richienda pana A. Saka A and B should be connected somehow. They are formed by this same imaginary chord. They are inside the same major segment panapa. That's something you should emphasize. So what I was trying to explain is mukatarisa muchaona kuti vertex, 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 vertex. Now taku minor segment, vertex, vertex and also the vertex. So this is the second theorem we are looking at. Again, inoti angles in the same segment of a circle are equal. Let us meet in the next lesson. Did you discuss theorem number 3? It will talk about angles in a semicircle. Thank you, and I hope you learned something. If you have any questions, don't hesitate to ask. Now let us look at theorem number 3. Irikuti the angle in a semicircle is a right angle. So if we have a circle and we have a diameter, so a diameter is a special type of a chord because diameter rinofangwa kunge riri a straight line from this part of the circumference through the center, and I repeat, through the center chinobata another part. So this is the center O. Saka kana tine diameter tinenge tahafura circle redu into two equal parts. Saka this part A is going to be equal to the part B. Ndo zvinoreva kuti diameter. Saka tiri ipapo zvoreva kuti with a diameter, or let us just digress a little, with just any chord tanga tichigura our circle into a minor segment and a major segment, and we demonstrated this earlier. But with a diameter passing through center O, tiri kugura our circle into two semicircles. So a semicircle is also a special kind of a segment. Two semicircles. So we have semicircle iri kumsoro kunoko neiri pazasi. Theorem number 3 iri kuti the angle in a semicircle is a right angle. The angle in a semicircle is a right angle. What does it mean? It means, as you can see, kana tiine a circle and to specify a center O, tova ne diameter, then togadzira a triangle with a diameter kuti tive ne a vertex kana kuti a point inenge iri pa circumference like this. This angle is going to be 90 degrees. So they like this vanoifarira theorem iyi because it can be tricky. What you just have to notice is this: do I have a diameter? And kuti move in a diameter, it's not guesswork. You should have a specified center, which is O in this case, and your diameter should pass through the center. Kana tiine a circle like this, for example, this is O, tova ne a line riku njenga like this. This is not a diameter. This is a chord. Simply because haisi kupfuura nepasenda. Kana tiine line rakadai so, rakadai, rodai. This is not a diameter because a diameter should be a straight line. Iri kuconnecta, technically speaking, two opposite sides on the circumference. And saka two opposite sides on the circumference connected by a line passing through the center. Saka izvi zvataurwa, chatakuda kuita pano manje is to go through a few examples. So we have this example like that. So this is the circle. Towane chord inoi, towane this line. Then toona kuti line iri kupfuura through the center O, and then todai so foot like this. Toatadai so. Toudzwa kuti this angle is 63 like that. Saka we want to apply ma theorems atinoziva kutsvaka ma angles api. Let us read the question. Question iri kuti in fig 14.15 PQ is a diameter of a circle. Saka PQ and is a diameter of a circle. Circle racho it's PMQN, center O. So this is M and this is N like that. If PQM is 63 degrees, find QNM. Correct, we have to find this angle. That is the angle we want to find. Tinowana angle iyo sei. Saka ma theorems aticha apply panapa nde aya. Since taudzwa kuti PQ is a diameter, so the moment you see pakanzi diameter in your question, you have to be careful. Theorem number 3 iri padhuze. Then we see kuti pane triangle here yagadzirwa panapa, and we see kuti we have a triangle which has been made, and triangle yacho nde ino ishi iri kuti Q yoenda pana P yoenda pana M. Saka vertex ino ishi, this point panapa, it's 90 degrees. and theorem yatashandisa kuona kuti PMQ. I would encourage kuti avewo manyorero amunoita communicating your answer. PMQ is equals to 90 degrees. You can then just write angle in semicircle. Angle in semicircle. Saka angle inenge iri equal to 90. Angle inenge iri pa vertex iri nechekumusoro. Okay, let me demonstrate what I mean. Take a draw just a simple triangle like this. Angle neta 90 and ino-ish. Because kuri kuti tanga tida kuva ne a perpendicular line which is going to be used as a base, it could be here. Understand? Saka the vertex of the triangle yagadzirwa a triangle which is inside a circle having one of the sides a diameter should be this. So this is the 90. But when you are doing circle geometry, you should have an eye. Mufunga kuva neziso. Ramuno shandisa kuita sei. Ramuno shandisa kubuditsa ma triangle. Saka you should be able kubuditsa triangle inoi. And ndichabuditsa physically, but mimi should train yourself kungoibuditsa yakadaro. Panapa taona kuti it's 90. Then panapa, pause, let me label it kuti zvive clear. Q PM. Sataona kuti pa angle M pana 90. Panapa panani 63 degrees. Saka tikuda kuziva kuti angle iyi ndeyani. Zvichanetsa here zvama. Zvichanetsa here. Hazvichanetse. Saka angle P plus 90 degrees 3 pa M plus 63 degrees is equal to chi 180 degrees. Angles in a circle, in a triangle, I'm sorry. This will be the reason. If we add this, 0 plus 23, 9 plus 6, and 15, and so this is 153, like this. It's equals to 180 degrees. Saka P equal to chi 180 minus 153. So this is how we do it. 7, 8, 9, 10, 6, 7, 8, 27 degrees. Moto ya molebla panapa kutichi 27 degrees. Like that. But taona utapo it's 27 degrees. Takuda kutsvaga this angle. Angle iyi haifangu kuti netsa. Nepamusana pekuti as you can see, titori ne chord QM. Then we can tikaita that hand gesture yandaratidza paboard. We see kuti this angle P and N are going to be equal to each other because of the second theorem, not angles inside the same segment are equal. Saka angle P ingeri equal to angle N because the angles in same segment. And saka you should have an eye for this. Therefore, angle yatiri kutsvaga QNM is equal to 27 degrees. That is what you do. So it's as simple as this. Saka patacombine two theorems. That is what you should learn. Kana tichita ma questions aya. We are always going to combine a lot of theorems. Question ayiwi ichifunza one theorem. Zvinoya zvakabatanidzwa. So you should know your theorems intimately and be able to apply them. Before we keep this lesson, let us practice with a few examples here. Saka panapa some questions ndichamabuditsa ndomaitira paside, some questions ndichamaitira ipapo dependent on the level of difficulty. But panapa, as you can see, kuti this angle and this angle and this angle should be equal to each other because they are in the same segment. Saka natapiwa 40, zvoreva kuti A inge equal to 40, B inge equal to 40 again. And it. Saka taona kuti A equal to 40, B equal to 40. Sorry, A equal to 40, B equal to 40, then this central angle is 40. Can you find angle C? ndo wamfunzo wangu. Saka since I've helped you here, I'll keep this as a homework. Ndio homework yenyu yokutanga. Then can you see kuti angle ish ndi 90? Because the line redu rino iri is a diameter iri kupasa through the center O. And triangle iri kugadzirwa ne diameter ino ish nde ino e triangle yandiri kutrace with this arrowhead. Saka this angle in a semicircle should be 90. Then taona kuti angle is 90. Can you see kuti, let me just label xy, kuti this chord xy iri kugadzira these two angles, 115 plus this angle D. So D will be also 115 angles inside the same segment. So you have to repeat these questions that we discuss. If you fail to get to the correct answer, then you tell me and I'll create a video explaining some of these things. But I want to do number 3. So number 3 ndoda kuita payo yega like this. Number 3 tichaiona patichaita theorem number 5 or 4. I'm forgetting the actual number. But when we are going to do cyclic quadrilaterals, because this is a cyclic quadrilateral. So this is G, F, and 56. But taudzwa kuti this line is parallel to that. We have been told that this line is parallel to that. So that's important. H, like this. And taudzwa futi this is the center O. Saka, this is a diameter. Kureva kuti this angle F is equal to chi? 90 degrees. Angle in semicircle. Like this. And this also would be 90 degrees because of the same reason. But atina kunziti itsvage saka it's no need to know that, but it's important. Then manch, we should also know kuti angle G inoi inenge iri equal to this angle. Because of what? Saka angle E iri named inenge iri equal to angle G. Because of chi, because of set angles. So we are going to discuss angles, but we have what are called set angles. Kana chiti set angles trikuti. If we have two parallel lines like this, and we have a transversal line, rakada iso, and it saka iri line iri parallel to this line, and tovane a transversal line. Chinongonzi transversal line, a line rinogura nepakati pe two parallel lines. Angle ino ish yanda shedai inenge iri equal to this angle. Look at it closely. This forms a set. So we just give it a nickname, set angles. And they are called set angles, which is important. So those are tukuona futi pano. Then what is G? G chanetsa ere yama. G haifangwe kunetsa for a simple reason. Nekuti if this is 90, zoreva kuti 90 plus 56 here plus G should be equal to 180. Saka 90 plus 56, 0 plus 6, 9 plus 5, 10, 11, 12, 13, 14. 146 degrees plus G is equals to 180. Kureva kuti G iri equal to chi? Tikaendesa 146 kuside ukunosvika iri negative. 180 minus 146. Like this. Saka this is now 10 minus 6. That's 4. 8 minus 5. 5, 6, 7, 8. That's 3. 0 upper. Saka it's 34 degrees. So G is equals to 34 degrees. But since theta take note kuti G is equals to is equals to 34 degrees, and taona kuti this also will be 34 degrees because of set angles. So rot tana 90, 34, H in fange equal to chi 56. I don't know if you saw it. Kuti tanga chazongeta the same thing panapa. Tachigona ngoibuditsa triangle yachakadai. Itaona kuti 90. then taona kuti this is going to be 34 because of set angles. Saka ino iyi angle inenge iri chi. Of course inenge iri 56 because angle ish kana kuti triangle iri pasi yava similar to triangle iri pamusoro. Saka kana apa paina 90 apa 56 apa 34. So kuti apa in 90 34 56. Just like that. I hope I explained myself well. Panapa I plus j is 90 because of angle inside the semicircle. But we also know that angle ino e yandiri kuindicate apa ne angle ish zvinenge zviri equal because of angles inside the same segment. So using that information, how can you be able to find my angles ari kudiwa? How are you going to be able to find my angles ari kudiwa? I leave this to you. Inoda kufunga zvishoma as a homework. Saka I'm going to summarize your homework after. Then this one, K aifangu kunetsa, I want to leave this as a homework too, but let me explain it. Because this is a diameter angle in a semicircle. Saka kuroti K inge equal to 90 minus 53. And it. Saka kana K equal to 90 minus 53 towana K panapa inge iri futi 90. Saka ndi I achanetsa iri. Kana tine two angles mukati me triangle echi3 inonetsa kuwana iri. Figure that on your own. I don't want to explain anything. But as you can see, this is going to be 90. This also should be 90. And angles are in the same segment. P inge equal to M. Then you can go figure. Panapa it's almost pachena. Angle ish ne E should equal to each other. This is also a homework. How are you going to do it? Maybe let me help you number 8. Saka number 8 yakadai so. We have a center panapa verdai like this. 126 x apple W then to die foot. Panapa pana y straight line up panan set like that. Saka teacher ita say iya inetse W inofanirwa kuva 2 times 126. So W is equals to 126 times 2. Ichi angle subtended at the center is twice the angle which is subtended on the circumference. This is theorem number 1. Angle on center is twice angle on circumference. Like this. And it saka W equal to chi 126 times 2 12 up 2 times 2 is 4 plus 1 is 5 and 2 times 1 is 2 252 degrees. Toto yato enyora panapa 252 degrees. But x ichanetsere kuwana, x ichanetse kuwana because 252 degrees plus x so fonga kuva equal to 360 degrees. Reason complete revolution. Because this is angle this is the angle at the center. Saka panapa panofanga kuva ne complete revolution. Kuroti 252 plus x is equals to 360. Kureva kuti x inge equal to 360 minus 252. Tikadai apo 6 pano 801. 108 degrees. But taona kuti 108 degrees y ichanetsere kuwana. Saka rega ndichinje color ndiitire kunoku kuitira kuti zvive pano 1. Y achanetse kuwana because angle iri pakati panapa x inofanirwa kuva 2 times y. Kureva kuti y inge iri equal to chi x over 2. Saka tikatora half ya x tinowana y. Reason inoishi angle on center is twice angle on circumference. Angle iri pacenter inenge iri 2 times angle iri pacircumference. Angle iri pacenter inenge iri 2 times angle iri pacircumference. So you don't have to confuse it. Saka kana tine angle iri pacenter tichida angle iri pacircumference tinodivide angle yacho nani na 2. Asi kana tine angle iri pacircumference tichida angle iri pacenter tinomultiply angle yacho nani na 2. But angle yacho should be an opposite, like as you can see w ndo iri kurelate ne angle iri panapa, then x iri kurelate ne angle iri uko. Saka there's a sense of opposite somehow somewhere. So panapa munongonyora the same reason iyo. Saka y inge iri equal to chi 118 degrees over 2 into 2 1 into 10 5 1 up. Saka y apo iri equal to 59 degrees. Zeta chanetsa here, zeta chanetsi, because z plus y should give us 180. What is the reason? Angles on a straight line. And it angles on a straight line. Saka z, alright, it's z plus y. Saka z inge equal to 180 minus y. Kureva kuti 180 minus 59. What is 180 minus 59? Take out 180 minus 6 12 18. Saka it's 12 18. Kureva kuti inge reaching 120. Saka let me just do it. I'm not good with mental work. Okay. Saka it's 1 6 7 8. Saka it's 121 degrees. Anyway, and so in actual fact, owing to how we learn, lesson, you should repeat it. Your homework should actually be every question. Muchinyatso kuinyora pasi zvakanaka. Saka your homework is basically exercise 14b. You write every question number 1 to number 8. If you have any question you come across ya kunetsai kuti yawanikwa say, put it in the comments. I will attend to you, help you understand. If necessary, even create a video explaining it. Otherwise, thank you for being patient with us. I hope you learned something. We will meet the next lesson doing cyclic quadrilaterals.